Hello. This is a Model 100, a TRS-80 Model 100 with a PDDuino, which is Jimmy Pettit's SD to TPDD Arduino code, running on a Adafruit Feather 32U4 Arduino compatible microcontroller, which is a very nice device for this job because it already has a SD card reader built in and a LiPo battery charger built in, battery manager. It will charge the LiPo battery. You buy these LiPo batteries like this. They're a couple bucks. They're cheap. They're small. They're made for these. Like this one here is usually made for a drone, for like a quadcopter or a drone. And they already have that JST plug on the end, and that JST plug fits that. That's a JST socket, and it will charge the LiPo cell from USB if USB power is supplied, or when the plug is removed, it will run off of the battery. And so it's just like a little UPS built in. And the only extra component you need to do a Tandy portable disk drive emulator is this TTL to RS-232 level shifter, which is just a pretty standard module with a max 232 or something similar. I can't read the chip, just barely. I'm not filming at high enough video quality. I can't read it in person either. Maybe they obscured it. It's basically a chip like a Max 232. It's an RS-232 level shifter, and that's it. That's the only extra thing you need besides the Feather itself. And then on top of that, this one is being powered by the BCR port. So it's running off the Model 100's batteries. And this is just a tiny little, very simple PCB that just has two connections in it. It just connects, a 9-pin DB9, a DE9F plug to the power pins of the USB. And inside the Model 100, that one of the pins on that is connected to the 5-volt rail inside the machine. So I'll turn it on now. Okay, I've done a hard reset recently, so the time is reset and the machine is wiped right now. And that is blinking right now because there is no SD card installed. So I have a little 2 gig card with a bunch of random files from the M100 SIG archive and Club 100 and Bitchin 100. So the Arduino code, I've renamed it PDDuino because my version is I took Jimmy Pettit's original SD to TPDD code and then messed with it. So mine's now a bit different. Mainly it's still his code. The actual TPDD protocol is all him, and the subdirectory support is him. TS-DOS extension, TS-DOS extensions that provide subdirectories. I added sleep mode calls and a little bit of cosmetic, I added to the subdirectory support so that the current working directory displays in the corner of the window here. Or if you're at the root of the drive, it just says SD:. So, and I did some stuff in the code that doesn't really affect anything at runtime, that just has to do with programming it to make it try to make it a little more flexible, and ported it to a couple of other platforms. So it needed a little bit of adjusting to work on the Feather. There's also a Feather M0, which is the same form factor, but instead of a 32U4 microcontroller, it's an M0 microcontroller, which is more powerful and 32-bit, and needed some changes. And then the first microcontroller I ported it over to was Teensy, and that also needed some changes for it to work on a Teensy 3.5 and 3.6. And Teensy 3.5 in particular is pretty interesting because aside from being a very powerful CPU with audio hardware, so we could possibly emulate a cassette interface and just all kinds of stuff. The Teensy has I forgot what I was going to say about the Teensy. Oh, it's 5-volt tolerant. All the I/O pins are 5-volt tolerant. So it's a little nicer for hacking with retro stuff. But if you're just using it for a TPDD, there really is you're not using the I/O pins for anything. All you're doing is the serial interface and the SD card. And in this case, all the boards I just mentioned, the SD card reader is built in. You're not even doing SPI to it. So, anyways, let's use it. So, I have a TS-DOS ROM installed right now, an actual, like an EEPROM. EEPROM. I have a TPROM, which is a little PCB that I made that has takes an EEPROM, and then you can load it with whatever you want, and it just acts like a standard old EEPROM. So I have one of those loaded with TS-DOS right now, just so I could repeatedly wipe and restart the machine and still very conveniently get right back into DOS. I also have a Rex. I have a few Rexes, but this machine, I don't want to put a Rex in it because it has a PG Designs RAM expansion, and Rex is not 100% compatible with that. But well, more specifically, it's not compatible with the software. The software to control the RAM expansion is not 100% compatible with the software to control the Rex. Hardware, the two pieces of hardware don't conflict with each other really. Anyways, so I've loaded TS-DOS. Now I will do the directory listing, and you'll watch. Right now the thing is idle, right? There's no lights on it, but it's actually running, but it's idle. It's in power save mode. All the time while it's waiting for anytime there's no serial traffic, no traffic on the serial port, it's idle waiting for the next traffic on the serial port, and then it just wakes up, processes the command, and goes back to sleep. So whenever the SD card is used, is being accessed, this light will blink. And on this module, there's a couple of lights here that they blink whenever there's for transmit and receive. So these are in hardware and it's part of this module. It's just that's just going to happen. It's just electrically hooked right up to the line. This one is controlled by software. There's there's a couple of lines of code in the Arduino source that I'm explicitly have commands inserted to light the light whenever the SD card is on. And actually, I also like the light. Let me turn this off and show something. For an indicator, there's no SD card plugged in. Now when I power this on, alright, it's blinking right now because it's checking for an SD card. There is no SD card. Goes to sleep for a few seconds, half a second, and then checks for an SD card again. It's just loops doing that. And each time it checks for an SD card, it blinks the light for a second. And that just shows you it's looking for an SD card. As soon as I plug this SD card in, it's going to blink rapidly a couple times and then go to sleep. Right? So that's just indicating that it got the SD card and then went to sleep. And now it's in its normal mode where it's waiting to process commands from the serial port. So it's basically just watching. What's cool about this device, it has hardware interrupts. And you can assign the hardware interrupt to the RX pin. The RX pin on the microcontroller has a hardware interrupt, so the device is asleep and it will wake if the RX pin does anything, if it goes high or low. I don't remember which. And so the instant the computer sends any commands, any traffic over the serial port, that will cause the RX pin to blink, and immediately the controller wakes up, and actually wakes up fast enough to actually process the very byte that woke it up in the first place. Like, it doesn't miss that initial byte. I think that's amazing that it can do that, but it does. Of course, maybe at 1900 baud, maybe that's not so amazing. I don't know. But in any event, it's working. It's asleep right now, waiting on a hardware interrupt. And so when I go into TS-DOS, all right, and then I'll do a directory listing. I'll hit F4, which will list the disk contents. And as soon as I do that, the lights will blink, and I'll get a directory listing from the SD card. Alright, just repeat it. And you see it says SD colon up in the corner here. And there's a handful of directories and a few files. So I'll go into a directory. Here, I'll actually use it. I'll use this to load the PG Designs utility to control the RAM expansion, because since I did a hardware reset on this, I'm in bank 1 of that RAM expansion, and that bank has cleared out, and so that bank doesn't have the utility to control the RAM expansion, so I have to reinstall it, and you have to use a TPDD to do that, because you can't do it over a normal, like a telecom session. There's stuff in the basic file that won't make it. There's binary characters in the basic file that if you try to transfer it the normal way over a telecom session and capture it, it won't work. So you need a TPDD. Or any other binary transfer. If you had this recorded to saved to a cassette file, that would work too. But I don't know of one of those. So I need to, if I want to reinstall it's called zero menu. I need to copy this file, menu.ba, via TPDD. I need to copy it in a binary safe way into the RAM. So I'll load that now. And just hit enter. It's doing the traffic. Nope, it's already done. I'll go out. Well, let's load it up and run it. Why not? 8. How many banks total? Oh crap, I did this wrong. What bank are you in? 1. How many banks total? 8. Alright, and now to use it, it's not obvious at all. You have to read this from the manual, or somebody has to tell you. It doesn't look like it did anything. In fact, the menu.ba is gone. But what it did is it did install, and what you have now is you have to blindly type zero menu, the number 0 and the word menu, and that runs a program called zero menu, and then you can actually see that it did something. You just blindly type it in, even though you can't see anything that says that. And now, you see my F key is, say, bank 1, 2, 3, 4, and this up in the corner is indicating which bank I'm in. I'm in bank number 1. And so now if I press, say, F5, I will switch to bank 5. And you see I have different contents in RAM. I have a copy of Teeny on here, and it says I'm in bank 8. Why does it say I'm in bank 8? There's bank 5. Oh, I must have pressed F8. I pressed F8 by accident. So F8. You know why? Because I pressed the button that was under bank 5, and that's F8. There's F5. F6. I pretty much have... I don't really have... No, there's Ultimate ROM 2 in its config file. Oh, no menu. No menu program in there. Maybe it's just out of RAM right now. Let's try it. Yep, it was installed. So you have to do that install on each bank. I'm totally digressing here. This was not supposed to be a video about the PG Designs RAM expansion. So now I'm in bank 7, 6, 5, 4, 3, 2, 1. There's my TS-DOS. Alright, and see, it remembers where you are. I'm not sure that's a good thing, actually. I think I would... anyways, I'm left off in the PG Design subdirectory. So I'll hit enter on parent. I'll go up one directory. Now I'm at the root of the SD card. Let's see what's in util. Alright. I don't know if I have any more subdirectories, like multiple levels of subdirectories. Nope. Everything's one layer deep. I think it goes multiple levels. I just don't have any on this card. Oh, I think that was 2 levels just there, wasn't it? Parent. I'm in view 80. I'm in a directory called view 80. Parent. Oh, that was the root. Okay. Still only 1 level. Right, now this time, every time I do anything, the lights blink to load a little bit of data from the SD card. And that's all running off of the BCR port. Now the question is, how bad are we taxing that BCR port? Because it's not really supposed to be supporting a lot of power. It normally just runs a light, you know, just a small LED that just doesn't draw very much current, just to make a light, you know, and a transistor to sense the light. For, you know, it's all the barcode reader is. Well, let's see. Get this to lie a little bit flatter here. Okay. So, it's getting 4.9 volts. It's currently idling at 2.5 milliamps. And that's when it's asleep waiting for instructions, you know, waiting on a hardware interrupt. And that's typical. I just tested a whole bunch of different SD cards in the reader, in the Arduino, and I had one card that drew 6 or 7 milliamps, one that drew 3.5. Most of them made it draw about 2.5 like this. And so let's restart it all. So it draws a little initially when it wakes up, scans the card, then it goes to a very low sleep. That 1.4 is very low. Sometimes it drops, it settles at 1.8, but as soon as I use it and do anything, it won't go back all the way down to 1.4 like that. It'll go back to 2.5, 2.2, 2.5. And so let's load up TS-DOS, cause some traffic. Alright. Now watch the milliamps. Oh, I already hit the button. I didn't intend to. I must have brushed it. What I wanted to show... Oh, look at that. It did go back down to 1.4 milliamps. I'm going to hit the F4 button. It's going to load the disk, which will cause traffic to the Arduino. And the milliamps will go up briefly. They'll go up to 10 or so. 10 or 15. Yep, just peaked at around 140. I mean 14. There we are. See, it settled when it was done. It settled at 25, 2.5 milliamps. And this little gadget has a neat little graph display. It's not really useful because there's not numbers. You can't really get numbers off of it, but you can see the relative ups and downs. So I'll hit F4. It's idle right now. I'll hit F4 to cause directory listing. And you'll see some traffic. and then some elevated draw for a few seconds, and then it'll drop back down to fully idle. There's the traffic. Oh, that's interesting. It went idle a lot. Yeah, there we go. Scale is a little bit different than the last time I did this. Alright, cause the traffic. And then I guess the yellow line is voltage and the blue line is amps, is current. So when it's drawing a little bit more, the voltage is dipped a little and the amps is elevated a little. And I wonder how I can stop it from jumping around. Whoa. What's that? What's that? 5 volts. Oh, it's D plus D minus, which should just be nothing because this is just power, there's no USB data. All right. See, and there's where it goes fully idle. The voltage jumps up and the current drops down. That's the real power saving. So it's a little bit elevated for a second or two after it does the work. And then that's that. I forgot if I had anything else I was going to talk about. Oh, I could just show the LiPo battery. It doesn't need to run. It's neat to run off of the computer. It also can do this. Oh, it's not a reset button. That's a bootloader button. I don't want that. I need to cut power. Alright. So it can run off of that LiPo battery. So at 2.5 milliamps, even this tiny drone LiPo cell for a drone is 105 milliamps. So that's what, like 30-40 hours of idle time, which is essentially 34 hours of use, 30 or 40 hours of use, because it is idle all the time when you're using it. And then they have bigger batteries that are hardly any bigger than that, but they could be double and triple the capacity. So even this teeny one is fine, let alone one a little bit bigger. So see, just runs off of that just fine. And then that can be charged. That could be charged from any USB source. pretend this is a wall adapter. You just charge that LiPo just by plugging in a USB power source. Alright, that shows that it's charging the LiPo. That's what that light means. I forget if it goes out or turns green, or I think it goes out. You know, it's charging right now. That's it. That's all you have to do to charge it, is just plug in a USB, phone charger for a while, a couple hours. And then it's good for weeks again, because it would take forever to use up that 105 milliamp hours when it's only drawing 2.5 when it's idle. So I don't know what's wrong with that file. Should have picked a better example. File could just be corrupt. I don't know, it might not even be a basic file. It could be a text file just named .ba.